You can build an absolutely perfect PC. I mean, it powers on smoothly, the cable management is completely pristine, and guess what? You can still completely fail your assessment if you miss one single detail. Right. Welcome to the high-stakes reality of the TESDA CSS NCII assessment. Getting the computer to turn on? Yeah, that is literally only half the battle.
Welcome to the Explainer. I am so pumped you're here. Today, we're unlocking the insider's playbook for the TESDA Computer System Servicing NC2 assessment. Think of this as your strategic masterclass. We are going to break down the exact rubrics and those sneaky hidden traps from the premium reviewer, all so you can confidently beat this assessment on your very first try. Here's our battle plan for today. We'll start with the assessor's watch list, then move on to hardware and OS assembly. After that, we'll master network cables, dive into systematic troubleshooting methods, and finally, wrap up with documentation and final polish. Let's get right into it. Section 1. The assessor's watch list. Let's look at this purely through the assessor's eyes. Before you even think about picking up a screwdriver, you've got to ask yourself what actually triggers an automatic failure. Because you need to know the critical traps that can end your assessment immediately, way before you even get a chance to show off your tech skills. Well, here they are. These are the absolute deal breakers. If you damage a component by forcing it, fail a continuity test on your network cable, or just forget to jot down your tasks in the service report, boom, you're done. But take a really close look at that very first point. Skipping ESD protection. Honestly, this is the silent killer of both computer components and assessment scores. So, electrostatic discharge, or ESD, is just the sudden flow of static electricity. Now, to put this into perspective, a human body can carry up to 35,000 volts without you even feeling the tiniest spark. But it takes as little as 10 volts, just 10, to completely destroy a microscopic MOSFET gate on a motherboard. Because you can't feel the damage you're causing, assessors will actively test you on this. They might just casually hand you a RAM stick out of nowhere. If your instinct is to grab it without being grounded, you fail that check on the spot. So the absolutely crucial thing here is making these setup steps a reflex. Number 1, clear your work surface and lay down your anti-static mat. 2, put on that anti-static wrist strap. 3, connect the strap to the exact same ground point as the mat. And 4, always store uninstalled components in their anti-static bags. Assessors are watching you like a hawk to see if you have that wrist strap on and connected within the first 2 minutes. Moving right along to Section 2, Hardware and OS Assembly, where precision is literally everything. We've got a standard 6-step sequence here, but I want to give you a massive pro tip. Do not assemble in silence. Actually narrate your steps to the assessor. Say things out loud like, I'm using 0 insertion force on the CPU, or I'm popping the RAM into slots A2 and B2 for dual channel. It proves your systematic thinking. Oh, and pay special attention to Step 6. You have to fully seat that 24-pin ATX power cable until you hear the latch click. A half-inserted ATX connector is hands down the leading cause of random shutdowns and post failures during this exam. And this brings us to a critical operating system choice you have to make when creating your bootable USB in Rufus. You're choosing between MBR and GPT. MBR is a legacy format. If you use it, you literally cannot boot Windows 11 in UEFI mode. So, actually, scratch that. It's not even a choice. Always select the GPT partition scheme and UEFI target system for modern builds. It's a non-negotiable requirement. Okay, Section 3, Mastering Network Cables. This is the single task with the highest failure rate. You have to terminate these cables flawlessly. The assessor is going to plug your work into a LAN tester, and if even one single LED out of 8 fails to light up in perfect sequence, you get an immediate rescore. No pressure, right? To survive this, you need to anchor the T568B standard into your brain. Just drill this color sequence: white-orange, orange, white-green, blue, white-blue, green, white-brown, brown. If you ever need to make a crossover cable, one end stays T568B, and for the other end, the T568 side, you just swap the orange and green pairs. That's the whole trick.
While we're on the topic of networks, you're definitely going to face oral questioning, and the OSI model is basically guaranteed to come up. This breakdown covers all 7 layers, from physical cables way down at layer 1 up to application browsers at layer 7. If you ever blank out under the pressure of the exam, just use this top-to-bottom memory trick. All people seem to need data processing. Application, presentation, session, transport, network, data link, physical. Boom! Works every single time.
Now, when it's time to actually configure the network, you'll most likely need to set up a small LAN using a standard /24 subnet. With a 255.255.255.0 subnet mask, you get exactly 254 usable host IP addresses. Just memorize this default setup. Knowing exactly what a /24 means without having to think about it will save you precious minutes of calculation during the exam. Let's jump to Section 4, Systematic Troubleshooting Methods. It's time to diagnose those seeded faults.
Listen up, because this is the golden rule. Assessors heavily penalize random part swapping. If a PC won't display and you just start yanking out RAM and swapping power supplies without any kind of plan, you are going to lose major points. You have to use this exact 6-step method. Identify the problem, establish a theory of probable cause, test it, create an action plan, implement it, and document the whole shebang. And remember, you absolutely must verbalize your theory to the assessor before you touch a single screwdriver.
Let's quickly run through the most frequent seeded faults they're going to throw at you. No display? Go ahead and reseat the RAM and GPU. Hearing 3 long beeps? That's a classic RAM error, so try a single stick in the A2 slot. Getting a weird 169.254 IP address? That's an APIPA address, which means your DHCP failed, so you'll want to check your router connection. And what if you have a broad failure where absolutely nothing works? Time for a breadboard test. Take the motherboard completely out of the case. Assemble just the PSU, CPU, 1 RAM stick, and display. If it posts perfectly outside the case, you instantly know a misplaced standoff is causing a short circuit inside. Down to our final stretch, Section 5, Documentation and Final Polish. This is where you truly secure that passing grade.
On the software side of things, you might need to perform malware remediation. We've taken the standard 8-step protocol and condensed it into these 6 highly actionable steps. First, obviously, isolate the PC so the malware can't spread. But look super closely at Step 2, backup uninfected data to external storage. This is huge. Some aggressive malware will actually corrupt files during the removal process. If you delete a virus but lose the client's data because you skipped the backup, that is a critical failure. Always back up first. Then boot into safe mode, update those definitions, and scan with multiple tools. Finally, we absolutely have to talk about documentation. There are a few different logs required depending on your specific task, but here's the insider secret. Documentation is not an afterthought. Yes, the service report is mandatory at the end of the task, but if you wait until the very end to fill it out, you are almost guaranteed to run out of time. The ultimate key to passing this whole thing is filling out your service report and troubleshooting log while you're working. Write down your theory, test it, document the result right then and there, and then move right on to the next thing.
So, what does this number mean? 1. That is the exact number of attempts it takes to pass this assessment if you walk in systematically prepared, rather than just relying on being a smart, self-taught PC builder. I want to leave you with this really powerful final thought from the reviewer. Build with precision, troubleshoot with method, document everything. You see, it's not just about getting the system to boot up, it's about proving you have the strict habits of a trusted, professional technician. So the real question isn't just whether you can build a PC, it's whether you have the discipline to prove it under pressure. What habits are you going to change in your very next build? Thanks for joining me on this explainer, and I'll catch you next time.